Hey everybody, welcome back to this course. In this video, I just want to go over some computer science fundamentals so that we're not so lost when we're making these Arduino programs. Right, so here is this document. All right, so computer science fundamentals. So we're going to talk about data types. We're going to talk about variables. We're going to talk about scope. We're going to talk about functions. Well, for functions, we're going to talk about statements. We are going to talk about conditions. We're going to talk about loops, functions, and algorithms. Data types, right? Yep, okay. That is a good list to get us started. So what is a data type? A data type is how we store information. Right, so we've seen things like integers, floats, right, and void. So void, integers, and floats, and these are the three main data types that we'll be working with in this course. There are also things called arrays, which I will introduce, and you will be able to exploit the power of an array in later programs that we develop, right? So void, well, this is just an empty data, right? So there's nothing here. An integer, right? So that we call that an int. This is it's an integer, right? So it's a whole number. And there are signed integers and unsigned, right? So for a signed integer, we could have something like -1. For unsigned, it usually starts at 0, goes up to 1, and so on. So these are integers. Floating point values are are real numbers. Real numbers. So real numbers are integers are a subset of real numbers. Real numbers include things like 0.0, 0.1, 1.0, right? So 1.1, -1.1, and so on. So these are the three main data types that we will be working with in this course. You can also have something like an array. To specify an array, it has some data type as well, right? So it can be like an integer array or a floating point array, but this is basically a contiguous block of memory. So let's just step aside and talk about memory. Right, so in Arduino and in C, you have to specify the type of your variable. Well, I guess that's going more into variables. So now let's just move on to variables and we'll revisit this idea of an array. So a variable is what we store information in. Right, so you've seen things like int LED pin, right, equals 9. Right, so here we are assigning, right, so single equals is an assignment operator. And we'll talk about operators as we go along, but it'll kind of just be a running discussion of operators. There won't be a specific section. So this is an assignment operator. This is our data type. And this is our variable. Right, so when we initialize a variable, right, so this is called initializing a variable. If we just had something like int button pin, without an assignment operator, well, then this is called declaring a variable. And if we have declared a variable and later on in our program we give it some value, then this is assigning value to our variable, right? So we have these data type, we specify the data type, we call the variable, we give it a name, give it a value, and everyone's happy, right? So you can have integers, there's a whole list of different data types that we can use to call to use for our variables, and that's specified in the Arduino reference. So moving right along, we have this idea of scope, right? So when we have our Arduino program, so we're talking about scope here. So when we have our Arduino function, we have our void setup, right? And then there's some code here. We have our void loop, right? These are functions, but we'll talk more about the idea of a function soon enough. So if we declare a variable, right, so int x in here, our loop function has some memory space, right? And now it has loop memory. And now it sees this x variable, right? So if we're over here in the setup memory, well, it doesn't see x because x is inside of the body, right? So this is the body, inside the body of loop, not inside the body of setup. Now, if we were to declare a variable int x above loop, then, well, let's remove it from loop, first of all, because that can become tricky. So now it's outside of loop, right? So now loop sees it and setup sees it because it's just floating outside of this, outside of the function. And if it's outside of the function, but not in another function, then it's in the main memory, right? So there's the main memory. And there's a section, right, dedicated for loops memory, and a section dedicated for setup memory. But since X is in main memory, loop and setup, their memory spaces, they see the variable X. And so that's just the idea of variable scope. If we were to declare it in loop, then setup wouldn't see it, and the rest of the program outside of the other functions would not see the variable X. But if we put it outside, then everything sees it. That's just a bit on scope. Now we can talk about statements. So statements. Well, this is a true or false. Well, they evaluate to true or false. Evaluate to true or false. Right. So we have these more operator theory. So we have operators. We have these things called Boolean operators. That will, so Boolean is in the sense that it's true or false, right? So we have relational operators that you are kind of familiar with. So like greater than, less than, greater than or equal to, less than or equal to, or is equal to. And these are just some operators that we have at our disposal, right? So we can say like, if, okay, well, now this is getting into conditions. So we could say like LED pin is equal to high. Well, now this is we're not assigning it the value of high, we're checking if it is high. So if that LED pin is on, right? So then, or like button, or say we're storing like some voltage in a floating point value. So voltage greater than some threshold, like 2, right? This is a statement. It's either true or false. So I think next we were going to talk about conditions. Yeah. So conditions we use to exploit. So we use statements to control the flow of our program, right? So at a very high level, this could be like if hungry, and then inside our body of our code, eat food, right? Something ridiculous. Well, maybe not so ridiculous, something like that. Right, so then we could, going back to like Arduino language, maybe if button, or I guess so we read the button pin. So digital read, I'm just gonna write dig read button. If we see a button press, then that's going to be high, assuming that we've got it configured like that. If we read the button pin to be high, then we want to, let's just say we turn on some LED. Right, so digital rate LED pin, whatever. Right, so in this case, we check this condition, then we do something when that condition is met. Otherwise, we just skip over it. We don't worry about the condition. All right, so we've talked about conditions. Now we can talk about loops. So loops, this is when we have a section of, or when we, I guess not section, when we have a process that we want to do repeatedly, right? So, I mean, just in terms of Arduino, you have your void loop, right? This is, well, let's just talk about the different types of loops. So there is a condition controlled loop. There's a count controlled loop. And there are infinite loops. And so these are types. Our void loop function, Arduino is an example of an infinite loop. It just runs forever in the background. If we had a condition controlled loop, so we could say like while and so here's a condition controlled loop. So we're just doing nothing while there's no button press, basically. Right, so this is our condition, and we have a loop that is doing something while that condition is met. And then we can have a count controlled loop. So like for int I equals 0, I less than 10, I plus plus, and something like this. So here we have a count variable. We initialize a count variable. Here we check the count. Here we increment, or we update the count. Right, so using this loop, we can count upwards. We can also do a count backwards. If we check greater than, and then do I minus minus or something like that. We update the count. So there's that. So this is, like I said, this is an example of a count controlled, because we initialize some count variable and we're iterating over some count. So those are loops. What else did we want to talk about here? Functions. All right, so functions, right? It's just when we have these are also called subroutines sometimes. This is when we have a process that we want to streamline, I guess, right? So we have something that we want to do, so we put it into a function. That's pretty much all it is, right? So Arduino has these built-in functions: void setup, void loop, and setup runs one time, and you usually set the pin modes, right? So pin mode is another example of a function, right? So we do like a pin and then mode, right? Where mode is like input or output, pin is this is like the pin number that we want to set up. So we've got our pin mode. These are all examples of functions. If you want to set up your own function, this is the format of it, right? So we say we have a function that turns on a sequence of LEDs and returns 1 if it completes successfully and 0 if otherwise. So since it's returning something, we need to specify the return type as integer, and we name the function turn on sequence. Doesn't matter what you name your function. And here we have our parameters, so maybe it has the LED pins LED 1 and LED 2. Now let's just say it turns on these two. So turn on sequence. So we can do a digital write, LED 1, set that to high, and then we do a digital write, LED 2, high, and so we turn them both on. Wait a second. We turn them both off. Wait a second. All right, so we can encapsulate a bunch of complicated instructions into a single function, so that if we want to do all these instructions, right, we can just go into our loop, right? So our main section of code, this void loop, just looks like this. We just make a call to this complicated set of instructions that we turn on like pin 5 and 6 or something, right? So it just looks a lot cleaner. Let's say we had like our turn on sequence, right? And then we have some other function that check voltage on a pin. So this is the status of this turn on sequence. And then if we get all the way down to the end, so we set status equals 1, so we've finished the set of instructions successfully, and then we return the status. So then we run through our turn on sequence, we update, we can store that return value into this variable called status. So status is equal to this, and then if status is equal to 1, right? So if we successfully turned on, right, maybe we have a function called check voltage, right, on some pins like pin A0. Otherwise, we just return, so we do nothing. I mean, so that's just the idea of a function. You can use it to encapsulate a large chunk of functionality, and just your loop will look a lot cleaner once you do that. All right, and then this ties directly into the idea of an algorithm. So algorithms, and these are just instructions for some process. And what you typically want to do is this thing called functional decomposition, where you take a problem and you break it into bite-sized chunks, right? So that we can implement that in some programming logic. So say my friend asked me so our friend wants a system to turn on a light for their hamster when it is too dark, and fill up a food bowl when the food is getting empty. Right, so we have like our Arduino, and it's got maybe some kind of photoresistor. That's kind of looks like this. So there's a photoresistor to detect the light in the room. Well, that's going to be connected to some analog pin, so we'll just call that analog 0. So we've got our photoresistor. There's our ground plane here, tied to ground. So we've got a photoresistor. We probably want a light, not a light, a weight sensor. And that's going to be some analog pin too, probably. So we got a weight sensor, this more complicated device. I'm not sure if it needs to be grounded or anything. Got a weight sensor. We probably want a servo. It's going to be digitally controlled, so kind of like a servo. Over here to digital pin, start at 3 here. Right, so we can control the servo to turn and like open up a food, like allow food to flow into the food bowl, something like that. Oh, and then we need an LED, maybe on pin 4. Yeah, so we got an LED here, and that's also tied back to our ground plane. I think the servo also needs a reference voltage here. Weight sensor, probably. Yeah, let's just tie everything to ground. Right, so we've got a rough sketch of our system. Now we just need to kind of like map out what it does. So we have start, right? So we have a software flow chart of this process that we want to accomplish. So start, let's just initialize, so turn LED off. This is the process, turn LED off. We want to set the servo in closed position so that food isn't just falling out of it. Right, and then we can check light, and then if the light, or we say Is it too dark? Question mark. And that's a decision, right? So if it's too dark, then we turn LED on. Process. And then we check weight. Process. Is it too light? So this is, if it is too dark, we turn on the light. Too dark. Well, if the weight is too light, question mark, then we set servo to open position, and then we wait a second or so, and then we set servo to close. So right, we set it open to let food flow. So close position, and then we go back to checking the light. Oops. We go back up here to checking the light, and if it's not too dark, so this is no, then we turn LED off. If it's on, well, we can just do that, and then we go this way. All right, so basically what I'm trying to get at here is algorithm is this big fancy word, but really what we're doing is we're breaking down a problem into simple steps that we can program into like some kind of control system. And once you have this flowchart drawn out of the different steps that you want to accomplish, programming it should be the easy part. It's getting the process down that's the hardest, right? So really understanding the problem and the fundamental things that we're able to control. Having the model of what it is you want to do will save you so much time than just trying to jump into solving it. So just opening up your IDE and trying to code this complicated process. You want to step back and write out what you want to do. So that should be sufficient for this discussion on computer science fundamentals. If we're still struggling, I will also take a step back and walk through how to do all this using Arduino. But thanks for tuning in. I'll see you guys next time.